Question number 1.16. The question says कि a heptane and octane form an ideal solution. At 373 Kelvin, the vapor pressure of the two liquid component are 105.2 kilopascal and 46.8 kilopascal respectively. What will be the vapor pressure of the mixture of 26 gram of heptane and 35 gram of octane? Right. So what is the system here? Once you will understand the system and the law that is using here, you will easily able to solve this question. So we have what? We have two components. First component is your heptane and second component is your octane, right? So as we know from Raoult's law क्या बोलता है कि आपका यहाँ पे सॉल्यूशन बना दिया हमने, सॉल्यूशन बना दिया तो इसमें दो तरह के आपके कंपोनेंट मिक्स है और दोनों तरह के लिक्विड में जो कंपोनेंट है वो गैसियस फेज में ही प्रेजेंट होंगे। गैसियस फेज में भी यहाँ पे H और ऑक्टेन प्रेजेंट होगा और उसका गैस यहाँ पे प्रेजेंट होगा, राइट। और जो O है, जो ऑक्टेन है, वो आपका PO आपका पार्शियल प्रेशर लगाएगा और इसका भी आपका हेप्टेन जो है उसका भी, क्योंकि गैसियस फेज में हेप्टेन का मॉलिक्यूल्स है तो उस गैसियस फेज में मॉलिक्यूल्स के कारण आपका एक हेप्टेन से पार्शियल प्रेशर लगेगा गैसियस फेज में। और ये जो पार्शियल प्रेशर होगा ये क्या होगा? इज डायरेक्टली प्रोपोर्शनल टू द मोल फ्रैक्शन ऑफ हेप्टेन दैट इज प्रेजेंट इन द लिक्विड, राइट। एंड सिमिलरली that partial pressure of octane is directly proportional to the mole fraction of octane that is present in the liquid. Simple. तो आप देखो कि टोटल प्रेशर जो होता है इज द सम ऑफ द पार्शियल प्रेशर। पी टोटल जो इस सिस्टम में होगा वो पी आपका हेप्टेन के कारण प्लस पी आपका ऑक्टेन के कारण होगा। सिंपल। और आप इसको कैसे लिखते हो? आप इसको, हम लोग रॉल्ट्स लॉ से इसको लिखते हैं कैसे? P partial pressure of heptane in the case of heptane is directly proportional to the mole fraction of heptane, and when we remove that directly proportionality sign, we can see that this is going to be partial pressure of heptane is equal to mole fraction of heptane into vapor pressure of heptane, right? So this is the equation of Raoult's law. Similarly for octane, what is it? Partial pressure of octane is mole fraction of octane into vapor pressure of octane. ये ओ ऑक्टेन के लिए है और ऊपर वाला जो है वो बता रहा है कि पार्शियल वेपर प्रेशर है ऑफ ऑक्टेन, राइट। अब आपका क्योंकि यहाँ पे टोटल प्रेशर निकालना है तो ये दोनों के कारण ही, ये दोनों पार्शियल प्रेशर के कारण ही टोटल प्रेशर बन रहा होगा। यही दो कंपोनेंट ही है सॉल्यूशन में। तो आपका पी टोटल जो होगा वो क्या होगा? PH plus PO, right? And that PH plus PO you can also write P mole fraction of heptane into vapor pressure of heptane plus mole fraction of octane into vapor pressure of octane, P total, right? Simple, easy. And once you understand this concept you can solve it very easily. So what is the given things here? Vapor pressure of P1 naught, that is obviously it has to be given for calculation, and vapor pressure of pure octane, that is P2 naught, that is 46.8 kilopascal, it has to be given, right? So this is given. Your mass of heptane that is given 26.0 gram, that is used to calculate the mole fraction of heptane. First of all mole, then mole fraction, right? So mass of octane is, this is given for the calculating the mole fraction of your octane, right? So once you know the mole fraction, once you know the mole fraction is going to be n by n plus n naught, and here you have to use the formula for calculating the mole, weight by given mass by molecular weight. Simple. So you know the formulas. Once you know the formula you have to just put the value. So molar mass of heptane is 100 gram per mole, molar mass of octane is 114 gram per mole, and now you have to use the formula for Raoult's law, that is Pt is equal to x1 p1 sat plus x2 p2 sat, means vapor pressure of that particle component and vapor pressure of that particular component. Simple. Now you have to calculate the moles, that is from the given data here. So 26.0 and divided by the molecular weight of heptane, that is 0.26 mole, and N2 is 35.0 gram given, so divided by 100, that is 0.307 mole, right? Simple. And once you do the sum, that is total mole, n1 plus n2, that is this. So now you can calculate easily the mole fraction. You can easily calculate the mole fraction here. So mole fraction is moles of heptane by total moles, that is 0.458, and mole fraction by mole of octane by total mole, that is 0.542. Simple. And once you do that, you have to just put that all these values in the formula. Pt is equal to x1 p1 sat plus x2 p2 sat, means vapor pressure. This is sat. You can also say it saturation pressure, vapor pressure, right? Vapor pressure is also equal to saturation pressure. Okay, same name. So you have to put that value here, all the value that you have got. This is x1, this is p1 sat, this is x2, this is p2 sat. This is for heptane, this is for octane. Simple. Once you have put all the data, you have to just calculate, and pt is 73.6 kilopascal, and hence the total pressure of that system is going to be 73.6 kilopascal. That means ki in this system that you have particularly drawn here, the gases of or the combined partial pressure is producing a total pressure of 73.6 kilopascal. 73.6 kilopascal. Simple. So you have to just understand the concept and laws and formulas, simple formulas. After that, you can easily calculate this.